All right, guys, we're looking at the notes for Wednesday, April 5th, and we're trying to evaluate these definite integrals. This is just review right here. These first couple are just review. We've already done these, but I just wanted to remind you that if we have a radical in the problem, we want to rewrite that problem so that we don't have radicals. So we would want to rewrite this as u to the 1/3 minus u to the 2/3. And to find this integral, I have to add 1. So if I add 1 to 1/3, I'm going to get 4/3. Rather than dividing by 4/3, it's easier to multiply by 3/4. When I add 1 to this, I'm going to have 5/3. Rather than dividing by 5/3, I multiply by 3/5. And then I'm going to plug in these numbers, 8 and 1. Here's the other part that people sometimes struggle with. And that is, what does that mean when we have to the 4/3 power? Well, this is our root, and this is our exponent. So if I see this, this means I have to plug in 8 and do the cube root of 8, which is 2. 2 to the 4th is 16. 16 divided by 4 is 4. Times 3 is going to be 12. So when I plug in 8, I'm going to get 12. Right here, I have to plug in 8 again. Cube root of 8 is going to be 2. 2 to the 5th is 32. 32 times 3 is 96/5. And then I have to do minus. And if I plug in 1, I know 1 doesn't change no matter what power we raise it to. So this is just 3/4 minus 3/5. At this point, you can get out a calculator if you want to. Probably can just do it without. This is 60/5 minus 96/5. So that's going to give us negative 36/5 minus, and then this part, this is going to get a denominator of 20, so that's 15 over 20, and this would be 12 over 20. So 15 minus 12 is going to be minus 3 over 20. And then getting this with the denominator, I have to multiply 36 times 4. I'll just go ahead and do this on the calculator. So we're going to have negative 36 divided by 5 minus 3/20. And then we should math frac that, and we get negative 147 over 20. You should always give your answers as fractions, because if you do round a decimal, then you're not giving the exact answer. This one, it wouldn't matter if you put negative 7.35, that's exact. But if I had something like this, and you round it to 0.02, that's not going to be an exact answer. All right, let's look at number 2 now. So on this one, we have the integral of secant squared. This would be something where you'd want to go to your green sheet. What is the integral of secant squared? Tangent, right. So we're going to have the integral of 0 to pi over 4 of secant squared t. That's the same thing as just tangent. And then we have to plug in pi and 0. So we're going to have to do the tangent of pi minus the tangent of 0. You can use a calculator here if you want, but to get an exact answer, it's a little bit better just to go ahead and do the unit circle. Oh, thanks. I didn't see the 4. Thank you. Okay, so if I want to find the tangent of pi over 4, I can think of my unit circle and I can think, what's the point there? Maybe some of you just know the tangent of pi over 4. That's the tangent of 45 degrees. Think about it. Opposite over adjacent. What's it going to be? Just, not for tangent. It's not radical 2 over 2. It would be what? 1. So this is 1 minus the tangent of 0. I can look right here. This is the point 1, 0. Tangent's opposite over adjacent, or in other words, y over x. So that's going to be 0, and so that's going to be 1. Now remember that you can actually use your calculator to check these. I would not recommend that you use them at the very beginning, but if I want to put in secant squared into my calculator, I would have to put it in like this. 1 divided by cosine of x, and I need this cosine of x to all get squared. That's how I type in secant squared. I need for this to get squared right here. It might even be a little bit better to put the entire thing in parentheses. Let me delete this one and insert it here. So this would be secant, and then I'm going to square it. I do a zoom 6, and then if I want to check out what this area is from 0 to 4, we can just go under second trace, put in your lower bound after you push number 7. Our lower limit is 0. Our upper limit is pi over 4, and it'll tell us that that area is 1. So we can double check. All right, so that's review. This is new. And this is important here that you can do this. Absolute value. We're going to evaluate each of the following. This can be done several ways. One way is by using the graphing calculator. I can literally type this into my graphing calculator and have it find the area for me. The second way is to find the total area by finding the areas of the triangles formed. I'm going to show you that way here in a minute. The third way is to evaluate the integrals by rewriting the function as the sum of two integrals. This is the part that I'm going to expect you to be able to show. I do not expect you to evaluate it, but I want you to understand how to set it up. Let me show you what I mean by this. If I graph this function, absolute values of v right here normally. This is a shift to the right 1. This is the way it's going to look. If I plug in 0, I get 1, so I know that point right there is 0, 1. If I plug in 4, I'm going to get 3. So this is the area that I'm trying to find. I can find that area pretty easily. This is 1, this is 1. This is 1, 2, 3, and I know the height was 3. These are just right triangles. So how do I find the area of a triangle? Just what? Base times height divided by 2, right? So this little region right here is going to have an area of 1 times 1 divided by 2, which is a half. This region right here is going to have an area, 3 times 3 is 9, divided by 2 is going to be 4.5. So this total area is 5. I don't really need calculus to do that. I can figure out the area without it. But the part that I want you to be able to do is to set up the integral that would solve this. So if I want to do that, I have to think of what we talked about in the warm-ups. What is the equation of just this part right here, of this line? Anybody know? What's the equation of this line? Negative x plus 1. Good. So I would need the area under negative x plus 1 from 0 to that vertex of 1. That would be the first part. This right here would tell me that area. To represent this area, I would have to say plus the integral. Where are we starting now? What x value is this? 1. And what are we going out to? 4. And then what's the equation of this line going to be? Think about the slope and the y-intercept like we did in the warm-ups. X minus 1, isn't it? So this would be the way that you would have to do that problem. At the college level, they're probably going to expect you to do it this way. For now, I want you to just be able to set it up because it's pretty tedious to now integrate this, plug in 1, plug in 0, integrate this, plug in 4, plug in 1. It's easier just to use the triangles. Okay? That other way I mentioned would have been to find the area by going to y equals, going under math, over to num, absolute value of x minus 1, doing a zoom 6 for our standard, then going to second trace, going down to number 7, and going from 0 to 4. And it tells us that that area is 5. Okay? So I hope that when you get into college level calculus and they ask you to do this problem, that you can think about what it really means. At the college level, a lot of times they fly through things like this, and they would just show this problem, go to this, expect you to integrate that. But I would hope that you could think back and say, hey, I can find that area just by thinking of triangles, and I can get the correct answer. And then you can at least write this and, kind of at least know what the answer should be. You see what I'm saying? All right, so this would be a formula that you would see that you could use to integrate. It would say the integral from a to b of the absolute value of cx plus d. This would be an actual formula that you would see in a book. How do I find out this kind of setup? It's going to be the integral from a, and then what did we say we did with this to find out what this top number was? Do you remember from the warm-ups? What did we say we do with this to find out where that vertex is? Set it equal to 0. Good. So I would take this cx plus d, set it equal to 0, and solve it for x. So x would equal negative d over c. That's what the vertex would always be. So I would need to go from a to negative d over c. Now, what would this part be, though? What did this turn into? What do we do to this to get that? Multiplied it or divided it by what? Negative 1. So I could say then that it's going to be negative cx minus d dx, right? Plus the integral from, okay, now where would we start back up at whatever that vertex is? What was that vertex? Negative d over c, so I go from negative d over c up to b, I wish I wouldn't have written that there, of cx plus d dx. Let's get rid of all that. And that would be a formula that you're going to see in a calculus book as to how to do that problem. Can you see how complicated this would be if you didn't understand what any of that, where it came from? That's the formula on how to find the integral of an absolute value function. Looks confusing, but if you understand it, it's pretty easy. Let's just set this one up. Try it on your own. How would we set this up to find this area? What numbers go here? What goes here? Fill in all this stuff. Think you know it? Raise your hand. All right, a couple of people had it. Casey, explain what you did.
I found the vertex by taking 2x minus 1 and equaling it to 0, and that came out with 1/2 of the vertex.
Good. Okay, so then what did you put here and here?
That's 0 to 1/2. And then I took the equation to, and then times it by negative 1.
Okay, good. So that goes there. And then what about for this part?
1/2 to 3.
Right?
And then I just took the actual equation.
There you go. That's how it works, guys. So on your quiz on Friday, I'm going to expect you to be able to do that. I may not make you actually write it out. It might be multiple choice or something, but you need to have enough of an understanding to understand how to set that up. Now, to actually find the area of that, I wouldn't really use this. Like I said, in college, they may not let you use calculators. Some college calculus classes, they don't let you use calculators at all. If that's the case, you're going to have to do it that way. But if we have a calculator, it's so much easier just to type it in like this, graph it, and then do our Math 7, and just go from 0 to 3. And we can quickly get that area. It's 6.5. Now, the calculator is not even exact on this. Calculus finds the answer exactly. This is an approximation of the area. It is probably 6.5 exactly. In fact, it is. Okay, guys, so we do have a little bit more of notes since it's block day. So let's just let's take a break for just a couple minutes, let that kind of